My story with this research has been motivated by my interest in the theoretical views of a true dwelling and meaningful spatial experience within the built environments, such as biophilic design, critical regionalism, and other theoretical views by Martin Heidegger, Norbert Charles, Robert Venturi, Tado Ando, Johanni Belasma, and others. First, I try to direct the research toward more exploration of these theoretical views and make them applicable throughout the design process. After spending a considerable amount of time reading through these domains to specify the starting point toward this goal, I think achieving a well designed visual connection to the outside environment might be an essential and common requirement for successful applications of these theoretical domains in the design process. Most importantly, I think that there is not much to do with these theories, but with the design process itself, specifically the context of the design process. I strongly believe that the issue in the context of the design process is due to the spatial and temporal differences between the actual context of the design process and the actual context of the building to be designed. This kind of difference might potentially lead to loss or bad managing the spatial data that could help to achieve a well-designed visual connection to the outside environment. This research aims to develop a framework to effectively merge the two contexts into one context by introducing 3D geospatial data into the design process. For better understanding of how this research has developed a proposed framework might contribute to solving this design issue, I conducted a logical discussion with an imaginary character who represents the curious side of me. The answers to the asked question explain the framework's main steps, its workflow, the integration possibilities with the design process, and its potentials and limitations to be developed into a friendly use digital design tool that might help designer to achieve a strong visual connection to the surrounding environment from inside out points of view.
First of all, can you briefly state what you are doing in this research?
Sure, I'm building a framework for developing and integrating an explorative and evaluative inside out design approach to the current design process, augmented by a 3D geospatial data based context that merges the actual context of the designing process with the actual context of the building location.
Okay, but what do you mean by the best possible views?
I mean that not all explored best view could be framed because of other design consideration and constraint that should be considered throughout the design process.
Okay, but I think there have been many buildings with very well designed visual connections to their surrounding environments and they were designed without using your proposed design approach.
To some extent, you are right. However, the number of such buildings are few compared to the number of buildings designed or will be designed around the world. Relatively speaking, I think that the numbers of architects or designers who could intuitively establish a well-designed visual connection are few. Also, how could one be sure that these buildings have the best visual connections? There might be better visual connections that could have been revealed and achieved in these buildings using the proposed design approach.
As a designer, how using this approach would enhance my designing ability?
Great question. Apparently, this approach might expand designers' cognitive ability through exploring and evaluating multiple scenarios for visual connection to the outside views from any point within the location or spaces of the building to be designed.
Okay, have you tried to use the proposed approach with the current design process to design an actual building?
Of course, and I'm excited to share with you what have been done. In fact, the proposed design approach is designed in a way that helps designers to make the relevant design decision in a gradual and careful manner throughout the design process.
A gradual and careful manner? What do you mean?
I mean that by integrating this approach to the design process and according to the design stage being carried out, designer could conduct specific level of 2D and 3D exploration and evaluation of the visual connection to the outside context. This might make the design decision more informed and the visual connection stronger. The series of the 3D and 2D exploration and evaluation inform different design decisions during the design process, starting with major design decision regarding the main building layout, massing and orientation, then more specific design decision regarding the position and shapes of the openings on the exterior walls, the interior wall configuration, and furniture arrangement. And finally, design decision regarding details of any design element which might influence the quality of the framed view, such as the design of the openings.
What are the details of these, the 4 or 5 main steps of the framework?
Before that, I want first to talk about one essential step to the framework to become applicable, which is building a 3D digital model of the existing world.
Why have not you considered this step as one of the main steps of the proposed framework?
In fact, it might be considered one of the main steps, but not in the long term of using this design approach. I assume that such of these 3D digital context model will be available and accessible in the near future. 3D digital and smart model for many cities have been developed across the world, such as the 3D Blacksburg model, Paris model, Berlin, and other cities.
If so, why not you have considered this 3D digital context model available and go on to the main steps?
In fact, the available 3D models have not yet developed in a way to be accessible by architects through their design tools to support design decision for designing an individual building. Unfortunately, the current integration between the 3D geospatial domain and architectural domain is dominated by one-way workflow from the architectural domain into the 3D geospatial domain, not vice versa.
So what have you done to overcome this issue to provide accessible 3D digital context model through using your proposed design approach?
Simply, I have built one by using the InfraWorks 360 software.
I think this software is more for planning and designing infrastructure projects in the context of real world.
Yes, you are right. I took advantage of its ability to aggregate several 3D and geospatial data to build a 3D model of the real world where the proposed project will be located. First, creating a base model of the area of interest consists of vector and raster data such as building, terrain, water areas, and roads. Second, adding more 3D geospatial data such as the vegetation layer in the form of pointy cloud data extracted from LiDAR data.
Do you think that was enough to inform your relevant design decisions?
As long as the purpose is to explore views at the conceptual level, I think this would be enough. The key thing is to make design decisions based on determining the relative spatial positions of each of the design elements, context elements, and the space occupants within the expected spatial experience. In other words, I think it's enough to achieve the psychological functions of orientation and identification as identified by Norberg Schultz. Step number 1. This step, through a series of the 3D and 2D exploration and evaluation of the quality of the visual connection, inform the major design decision regarding the building mass and orientation in order to frame and emphasize the best visual connections to the outside environment. First, the 3D exploration was conducted, then the 2D exploration. Moreover, the 3D exploration was conducted through two main stages: the inside 3D exploration, then the digital 3D exploration. For the inside 3D exploration, I visited the building site in order to explore the best views from several points within the building location. Also, I documented these potential views by taking several photos from each point and mapping the areas of these views.
If you already had known the best views from the site visit or the inside 3D exploration, why did you conduct the digital 2D and 3D exploration?
In fact, the answer to this question might justify a big part of the reason for conducting this research. There are many reasons for not only relying on the site analysis visit to explore the best possible views. The accessibility to the site is not always available for different reasons, such as the remoteness of the building site and the hazardous condition of the building site. Moreover, the explored views might not be the best ones, especially for elevated points in the case of designing a multi-level building, where a designer, even if he is at the building site, is not able to explore, evaluate, and frame views from these elevated points. Also, it would be very hard and inaccurate for a designer to explore, evaluate, and frame views frequently along with the progress in the design process.
Okay, then how did you conduct the digital 3D exploration?
First, I started navigating the built 3D context model inside InfraWorks 360. This gave me the possibility of freely exploring the surrounding context from any point within the building location, especially views from elevated points. Based on conducting the 3D exploration process, three main areas of interest were determined to be explored and framed throughout the design process: Virginia Tech War Memorial and Drill Field, Boros Hall and April 16 Memorial, and the Duck Pond. So, the determination of the areas of interest which might have been framed depend on both the inside and digital 3D exploration of the building site.
Then, how have you integrated these determined view areas of interest to inform your design decisions during the design process?
By conducting the 2D digital exploration process. Inside the InfraWorks 360, the geographic coordinates of the approximate center of each area of interest were extracted and exported in an Excel sheet to be used inside the Revit software. The extracted coordinates, latitude and longitude values, were converted into UTM coordinate system. Then, a Dynamo script developed inside the Revit software to generate three cylindrical shapes that represent the determined areas of interest based on their geographic coordinates and their approximate heights.
Okay, but how did the circular or cylindrical shapes contribute to conducting the 2D exploration?
The same Dynamo script was used to generate horizontal fields of view extending from the exploration points distributed at specific location within the building site into the tangent points of these generated shapes. These fields of view are represented by a range of radial lines of minimum 2 lines intersecting with the tangent point of each shape that represent an area of interest. For further exploration, the Dynamo script allowed to subdivide any generated field of view by increasing the number of the radial sight lines.
But why did you use circular or cylindrical shapes to represent the area of interest instead of using the shapes of real boundaries?
For the sake of simplifying the process. However, I know they are too abstract and might mislead the process, and it's much better to use more accurate and concrete representation of the area of interest.
How did you specify the number and locations of these exploration points?
I started with one point at the center of the building location, and more points were being added as the initial 3D layout of the building was developing. The final product of this step is a preliminary 3 digital model, Revit model, shows the main massing of the building and orientation influenced by the explored best views from the exploration points.
Do you think the generated fields of view might limit the designing cognitive ability regarding the building form origination and transformation scenarios?
Absolutely not. According to my experience, using them for designing the immersive case study building, I had a flexibility in developing various forms. The original motivation is to work as generic guideline within a force-based design framework.
Great! What the next after creating or modifying the architectural form and massing based on the outcome of 3D and 2D view exploration?
This was the level 1 of exploration and evaluation of the views. In the remaining steps, I continued conducting the other levels of the 2D and 3D explorations and evaluation to inform relevant design decisions. Step 2. In fact, the workflow of this step is similar to the workflow of conducting the first step, but to yield design decision regarding the configuration of the building boundary more than the building massing and orientation.
Did you use the same Dynamo script developed from the first step?
Yes, but for more number of exploration points, which were distributed according to the spatial analysis of the resulted spaces and mapping the expected spatial experience.
How did you conduct the mapping of expected spatial experience, and how did you know what's the expected spatial experience?
Based on the analysis of the spatial relationships, I assumed that there is some more expected scenarios of the user's spatial experience inside the building. Then I represented these spatial experiences by drawing colored SP line. Each line represents one of these scenarios.
What are your logical reasons behind doing that?
To guide distributing the exploring points within the created spaces until that moment, and therefore enhance conducting the exploration, evaluation, and adjustment processes. As in the previous step, the Dynamo script was used to generate fields of view from each assigned exploring point. Each field of view consists of minimum 2 sight lines that extend from the exploration point into the 2 tangent points of the generated circular boundaries of the areas of interest. The intersection areas between the generated fields of view and the external and internal wall informed my design decision. This included, to a great extent, the building boundary configurations, namely the position of openings on the exterior walls and the configuration of the interior walls, and to less extent, the building massing and orientation.
Did you make the design decisions about configuration of interior and exterior walls only based in 2D exploration?
Of course not. I used the InfraWorks 360 to conduct 3D evaluation of the quality of the framed views and make the necessary adjustment on the 3D model regarding the configuration of the external and internal walls. First, the 3D Revit model was georeferenced inside the Revit software. Then, it was imported into InfraWorks 360 and positioned in its specific location within the built 3D context model, which was built earlier. Then, the viewport of the InfraWorks 360 software was positioned at the center of each exploring point according to its elevation. Then, a bookmark saved for each point to facilitate moving between the exploring points. Then, I further explored and evaluated the views framed and seen from these points. Accordingly, several design adjustments were made on the 3D model of the building.
Did you make adjustments on Revit model inside the InfraWorks 360?
Unfortunately, no. InfraWorks 360 does not allow make modification on the Revit model, Any adjustment on the design was made inside the Revit software, and then the adjusted model was re-imported back into its original location inside InfraWorks 360 for further exploration and evaluation actions.
Was it better if the rounds of exploration, evaluation, adjustment could have been done inside one single software, either InfraWorks 360 versus Revit?
Of course, but this is not applicable yet. Hopefully, this research would pave the road for developer of this software to allow such a thing.
How did you know when this step should end and continue to the next step? Did you have predefined criteria for this purpose?
In fact, it depends on the number of rounds needed for the process of exploration, evaluation, and adjustment. It was merely a subjective judgment. I ended this step based on my satisfaction as a designer of the quality of the framed views to the outside environment. Also, there might be a possibility to share the outcomes with other members of the design team, clients, or the potential user of the space. Step number 3. This step can be conducted either a complementary or alternative step to the previous step, depending on the design constraints. Sometimes, some design projects or parts of them might face constraints that prevent conducting the previous step. Also, sometimes exploring and framing the best views might not be priority for the design.
What do you mean? Can you give some examples of these design constraints?
Sometimes there are site-related constraints, such as the shape or area of the allocated site. Also, sometimes there are program-related constraints should be considered, such as the necessary spatial relationships among the design spaces. Moreover, there are performance-related constraints, such as having space without direct visual connection or with a high level of privacy.
Great. Then how did you conduct this step in a way that deals with such constraints?
In fact, this step yielded a design decision very similar to the ones of the previous step, but through slightly different approach of conducting the loop of exploration, evaluation, and adjustment. Another Dynamo script was developed to highlight the segment of the exterior and interior walls through which most of the sight lines to the outside pass through. For doing so, this Dynamo script generates fields of view in various radial range from the aside exploration point. All the radial lines that represent the fields of view extending all the way to intersect with the exterior walls unless they stopped by a solid interior walls. Also, the intersections with the interior walls inform design decision regarding interior walls configuration.
Did you make openings on all parts of exterior walls that intersect with the 2D sightlines of generated field of view?
Of course not. This decision should consider two main factors. First, the functionality of the space. Some spaces function better without openings, or at least with a specific number or locations of the opening. Second, the density of the intersection.
What do you mean by the density of intersection?
I mean that the parts of the exterior walls that intersect with multiple fields of view extending from multiple exploration points were considered more for making openings unless other factors prevent.
And this means that framed views through these openings will be seen from multiple locations inside the building?
Exactly. Step number 4. This step is more an extension to the previous step, but it yields design decision relevant to exploring and evaluating the framed view through more elaborate design of the exterior walls and interior design elements.
Why did not just conduct two-dimensional exploration inside Revit?
2D exploration process is more abstract that does not reveal the quality of the framed view. Also, the 2D exploration is not effective to evaluate framed views between two different levels.
Don't you think it's complicated and time-consuming process?
I think it seems like this because I explained both the way of developing it and its integration framework to the design process, and the potential way of using it by designers.
Well, what's your future plans for developing this proposed design approach?
In fact, I'm looking forward to further developing this proposed framework into a specialized exploration tool that designer could fully use from inside one design software to conduct the loop of exploration, evaluation, and adjustment of the visual connection to the outside environment, through which designer could access the 3D geospatial context model interactively and conduct the loop of exploration, evaluation, adjustment in a seamless and integrated manner with the design process.
Don't you think it's complicated and time-consuming process?
I think it seems a time consuming process because I explained both the way of building and developing the framework and the potential ways of using it by designers. According to my experience, through using an initial version of it, I would say that it might require extra time for conducting the series of exploration, evaluation, and adjustment, but it will save more time, could be spent on going back and forth between the main design stages of the design process. In the end, I want to thank all participants for their valuable time and urge them to respond to the first round of the survey as soon as they have done watching this video. Also, please feel free to contact me if you have any question or comment.